Vamos a hablar en inglés, de how to make Drupal deployments with Linux containers, vagrant, and Docker. So, first, a little bit about me. I'm, as I suppose you all are, free open source software lover. I work at Acquia. If I'm talking too fast, please say. Where I do systems engineering. Also, I work for the Drupal.org infrastructure, which is worldwide. So we maintain the Drupal.org sites and infrastructure. Also, I'm a Drupalist and a big Linux enthusiast. Apart from that, I'm a father, artist, and community facilitator, let's call it that, in Drupal, Portugal. About my family, I have one kid. This is mi mujer y mi hijo, tentando ser saudables cuando vamos a comprar los mantimentos para casa. So I hope that this presentation is exciting for you, because it certainly is for me. But it is not an easy subject. First, I would like to make one question. Who is using virtual machines? Máquinas virtuales. And who is using LXC or Linux containers from here? Okay. And who is using Docker? Okay, so cool. I think this presentation is perfect for you, because it's kind of a start knowledge of this kind of technology. So, what is virtualization? Virtualization is when you have a virtual machine that acts exactly like a real computer with an operating system. Software is executed on the virtual machine and is completely separated from the underlying host, which means that you have una máquina dentro de una máquina. See? So why should I care? First, it increases your efficiency, also the availability, so you can move that machine from one server to the other, and it increases security, because never the underlying host, never the guest host is able to go into the host itself. And it reduces costs. Thank you, Hernani, for the Twitter, I saw it here. And it reduces the amounts of hardware that you need. No precisas tantas máquinas. And it reduces energy. So in the data center, you are using less energy. For instance, one of these examples is Amazon. And they have nearly 1 billion revenue. So it's big business, virtualization. These are the types of virtual machines platforms. As you see here, starting from the top, you have KVM, it works natively on Linux. Bosch, VirtualBox, you probably heard about that. VMware, Zen, that's what Amazon uses. Virtual PC and parallels. However, the virtual machines have a sad story to tell us, because they have a lot of overhead. They need a full-blown operating system, and they are very heavyweight, very heavy for running applications on the cloud. So, what is the solution? So, on Acquia, we do a bit of research, and we have time to investigate stuff. So, I've been researching cloud solutions exactly for this problem, the heaviness of virtual machines. And the conclusion is that containers used to be terrible. But that's the past. Because hope just arisen at that mountain there. And LXC is ready to roll on a recent kernel near you. Because, like the name says, it's Linux containers. So it uses the Linux kernel. So this is from the Linux journal, and it shows, can you see it? Maybe it's too, okay, it shows the layers that you normally have, the amount of layers that you normally have on a virtual machine, a typical virtual machine. As you can see by the image, you have several layers until you have reached the base host. So the performance is getting lost on those layers there. And this is the comparison, also from the Linux journal, of layers that you have on a container. So as you can see, the container is much closer to the host and is able to get more performance from the host. And here you have it side by side, so you can see actually the big difference there. Evolution. Why do we care about this? Because when you have 10 servers, maybe it's not a problem if they take, well, in the past it was a problem because it took like 8 to 24 hours to put a server up and running. Now with the cloud, you are able to take like 5 to 10 minutes to have a server running. But with Linux container, you are able to spawn a server like in 5 to 15 seconds, which is a big boost. So where does this nice idea come from? Has anybody here used the change root command before? Any Linux user here? Who uses Linux? Okay. So you know cgroups? Have you used? Who has used it before? You? Okay. So what it does is you change your mount point of the root to that place there. And everything that you start to do after that, it works inside of that root. So like, you can have the full tree of files, and you can have several file systems inside of one file system. But what if you want to control, like in a virtual machine, you want to control CPU, devices, processes, memory, disk space, network. The change root command is not able to do that because it will only change your mount point to that tree of files, but is not able to control how many CPUs or how much memory you are going to give the guest. So this is the big difference between the normal change root and the new way of using Linux containers. So for these two type of technologies, like OpenVZ and LXC, which they need a specific control over the host service, you can use cgroups. Cgroups is like something that is able to tell the guest, just use this memory, just use this CPU. Don't give permissions for the user to do that. Or these are the limits that you give the guest. If I'm going too fast, please say, okay? So this is not really an important slide. It's just for you to see that if you install an Ubuntu machine and you just do apt-get install LXC, it already has installed LXC and it's already configured for you. Of course, this is a work in progress. And later on you can get the slide from the internet, so it's not very important to take attention on this. This is more like a roadmap of security issues that are still being solved, but a long way has already been done for constraining security. For instance, I can tell you a funny thing. In the start, a guest could just pipe a reboot command to proxy's rec. So it could reboot the host. Now this is already controlled via app-armor, which reduces the problems in terms of that. So let's see. It's enough of theory. Let's jump quickly to the best part. First, we are going to see a video how to do this with vagrant, not with VirtualBox, but using that guy there. And what you'll get after this presentation is Drupal, the latest version, Nginx, PHP FPM, MySQL, PHP MyAdmin, XHProof, Xdebug, and Composer. So let's see. Let me put the other one. I think this is better.
Today we are going to demonstrate how to install Linux containers with a Drupal enabled, so you can easily develop on top of Drupal itself. And for that we are going to use a repo that I created on GitHub. It's free to use. It's
Can you see it?
To import, to issue bugs, whatever. It has pretty easy documentation, and it tells you what you'll get in the end if you install this. So you'll get Drupal, the latest version, Nginx, PHP FPM, MySQL, PHP MyAdmin, XHProof, Xdebug, Composer, and so on. So the first thing we are going to do is actually go to this site, which is the vagrant download site, and get the latest dev into our working directory, and then we can install it. So I have here a console ready for that, and you should.
I'm just copy pasting the commands that are on the page, so you can do this at home.
And
easy.
it's installed. The next thing to do will be to ensure that we have LXC and Reader installed. They're already there. And after this, we should check out by cloning the repo.
This repo is freely available on GitHub, so you can go there and just
do this actually because
clone it. Git clone
have
the repo. And please give a help. Submit some issues.
Here
Open source.
Drupal and make sure that we have it all updated. And it is. So the next thing to do will be to install the plugin for vagrant, which is vagrant LXC. It is a very neat project. And after this, we should vagrant up by stating that the provider is LXC itself. This is LXC. It's quite different from the normal VirtualBox that we are used to use with vagrant because it's much lighter. It is much faster and it uses the kernel of the host itself to perform all the tasks that it needs. So the concept of containers is a little bit like change root, where you have a directory which includes a full root file system with all the operating
takes around 2
system
minutes.
Inside, and then
This version.
we are just telling the Linux kernel to use that root file system and to put it up. So it's actually very, very light, and it's very good to deploy, to make fast deployments and then work on it. So in this case, what it is doing now, it's puppetizing via vagrant the whole container. So in the end, you will have a fully working Drupal to develop with. It's doing now MySQL, it's creating Nginx configurations, and so we are almost done. So the concept of this will be later on to be able, as you can see, it took 108 seconds.
Not bad.
So that's less than 2 minutes.
It's all built. Like
And
the whole
you
thing
get,
is built. You can just use it now.
Drupal itself installed into this.
And I'm going to show that.
Here. So the next thing to do will be to check if the container is actually working, and for that we just do LXC minus LX, and then have a fancy layout of the output, and we have this IP which I can use to actually connect directly from my browser to that container. So for that we should redirect our port 80 from this box.
All these instructions are on that page. It's like 6, 8 commands, not more.
We can actually see what I did here on JPCOs, which is to name my local host as Drupal and teaching my ID and cgroup. So now I can actually open the browser and browse it. So just by, so we can see the local host has Nginx as expected, so it's connecting directly to.
It's not running on the
container.
actual machine. I have, it's running inside of that machine on a container.
Will show me the
But I can develop on that,
the
and I just
container,
can tear down,
is
create
ready
again,
for install.
Drupal installation.
And if I browse, for instance, another thing that's there, like PHP MyMe, I'll be able already to manage the database. So this is fully secure because you're working on your local host, and the project itself is very
Okay. The end of it. Let's go back to our presentation. So recapitulating, you can get the code from that URL there. It will be on the slides. They will be on DrupalCamp Spain site. And you can just use it for building that. But do I have to build this every time? Like, do I have to wait like 2 minutes every time I want the machine spun up? It seems that we have a problem here, and we need a solution. So the solution has arisen not so long ago, and it's called Docker. That Docker. So you can just create the image and then ship the image within a container. And Docker uses, Docker enables any application and its dependencies to be packaged in a lightweight, portable, and self-sufficient container, and then to be sent anywhere for deployment, like it's already built. So developers or engineers can build their application once and rest assured that it will run consistently anywhere by the operators. So the main container that the developer builds and tests on a laptop, for instance, like mine, will run at scale in production on virtual machines, bare metal servers, anywhere, even on OpenStack, as you are going to see. So these instructions are not really to go over now. These are really theory later. But you can import that image to a Docker container and then publish it and reuse it for later on. Or, again, you can just skip all of that and just use the Docker way. And for that, I have another project. And as you're going to see, okay. Oh, crap. As you're going to see, instead of taking
So welcome everyone to
instead of taking like 2 minutes,
on
it will take like 10 seconds now.
Containers. For this presentation, we are going to use a project I created on GitHub. And this project can be forked. It is.
Let's go forward. Sorry. Oops.
First thing we are going to do is actually install Docker on our working directory. Here it is. Next step will be to use the bash script from Docker.io to get the latest Docker.
Of course, course, you just install once, right?
And we should now clone the repo from GitHub. We go in.
It's cut. Sorry.
And
well, anyway, the commands are there, so you can copy paste them later.
build our container with the command that's on the documentation. So basically, we are building a container. It was very fast.
It was very fast,
the container
right?
To
like I gave the command. It
run.
didn't even took 10 seconds to launch the machine,
and
it's running already.
We run it. We just go and fetch your name.
So I don't know why.
That's how we do it. We're just saying here we need port 80 map.
Oh, now you can see.
Container here. So the container should be starting already, and it will do all the download of Drupal. So we should look into the logs and check if all is okay. So it actually went there.
It's running on the background. I just get Docker logs for that hash there and just see exactly what it's doing now.
So next thing to do is just buy a proof of concept. Go to the local host and see our Drupal installed. That's it. Thank you for watching. Please
So, just some slides more. So, Docker is really awesome. Like, you have all this set of options that you have that can control any machine, just incorporate into an image, transport anywhere else, or just make them appear on a repository where then you can just grab it and install like in 10, 100 servers at the same time. And one of the latest nice feature, which is kind of hacking, is that you can run Docker inside of Docker. It's kind of Inception. So you're just thinking, where can I use this? One of the biggest applications you can see for Docker is to use container layers, like you have cebolla, ¿sí? Tienes varios layers y puedes estar a desarrollar los varios layers and then adicionar los layers a cebolla, ¿sí? Y después pegas en la cebolla y colocas corriendo en otro sitio. Meaning, you can organize the containers inside your old hosting to be in constant development and commit always the last version to a centralized registry and then hand them off to operations for server deployments. This is especially good if you have like more than 10 servers, and then you don't need really to be always recreating the servers with Puppet, which takes a lot of time. Finally, changes to this container can be committed to the central index and then rolled back. To make this really, really automated and to scale really big, you can actually use OpenStack and make it manage your images and deploy the containers. Who has used OpenStack from here? OpenStack, anyone? Heard about it? OpenStack? Ninguém has ouvido de OpenStack. And this is done by the Nova driver. So you can actually call the Nova driver, which supports a bunch of providers. And for this is .cloud, which is the developer of Docker, has created this integration. Finally, changes to the container can then be, no, sorry. I think this was the last slide. No? Yes, this was the last slide. Okay, questions? I think this is like, it's really, yeah. I can see in your faces, it's like, oh, what the hell is going on here? But this is going to change the future, and it's going to change the way that we actually see deployments of servers. So if you have any questions, please go forward now. Any question, like even the dumbest one or the smartest one, doesn't matter. En español, si quieres. ¿Sí?
When you talk about Drupal deployments, there you're deploying the server, but
Sí.
how do you deploy the code and the database afterwards on top of it?
It's already deployed.
It's
like,
inside.
Yes.
But how do you make it transition? I mean, if you have something in production, can
If
you
you
use
have
this?
some-
Can you use this to update production?
Ah, yes, yes,
But
yes.
How do you keep consistency?
So
The database is running in production, and then you make changes to the
we're talking about Docker, right?
yeah.
Okay.
And then you're just making changes to code and maybe configuration, whatever, features, whatever, and you push your new container. Doesn't that include the information in the database, like hot?
Exactly. It can include any documentation, any layer. This is the best part of it. It can include any layer. Like you can have the Apache files like a layer. Like one commit was the Apache files, and you committed that to the image. Or you can have the Drupal code as one layer. Or you can have the Drupal code as several layers. Like you just deploy one part and then the modules. You can divide it by layers, and then you can just grab the layers that you want. But the best way to do it is like when you have, because you're not going to have overhead, you can have one machine for MySQL and another container for Apache. In this case, I'm doing everything in one, which is not the best way to do it, because then you cannot scale, but it was just for this presentation. But then you can start to separate. Like, you have one machine for MySQL, and when you upgrade the MySQL, you're just going to upgrade with the newest image of the MySQL box and maintain the data, because the data is another layer. Okay? This uses AUFS, which is, do you guys have used live distros, Linux in Live CD? Okay. How does that work? You boot up the live CD, and then it mounts the root in two parts. One in memory, and one is on the CD itself, right? And it uses AUFS for doing that. Like, it's congregating the base layer, and then with everything that you are going to put in terms of files in there. But it's using memory. You can use either memory or even a disk. So you can put the two together, and it will match the latest version of whatever you have. See the...
And when you set up all these layers, are they aware, like, because you're actually, each layer is a container by itself, or not? Or are layers of,
it could be
within a container?
Good question. Good question. It can be a layer, but it can be separated in each machine. So like, if you get a machine with MySQL, you have like the kernel part, like you have here. Right? You have the kernel, and you have the AUFS, which is joining together all of the things that are static in terms of files with the other things that are not static and are changing, like the files of the site, right? Or the data of the database. And you can actually do it two ways. You can actually have all this in one container, or you can separate parts to each container. Okay? But I think to explain that, it's very confusing. It's better to just see, okay, for now we have one container. Because you can actually, it's like Drupal and Lego, you know? You can mix all the things. It's like a recipe.
And layers is a concept from Docker? It's a concept.
No, it's a concept, it's a whole concept. It's a concept of using AUFS and then having a base thing of files that are read-only, and then adding mount points that are changeable. And the kernel will recognize what part is the newest one. Okay? I hope it responded to your question. It's quite a difficult, actually, it was a very smart question.
Because if it's containers, you have to actually manage it as like a cluster by itself. Like you have to make connections between them, like network connection.
You can do that also. You can do that also.
You can, or you have to, because like when you have a container.
No, you don't have to do that. You can actually just have one layer, but that makes it not useful.
Yeah, but I mean, like, can you configure how they see each other?
I mean, like,
This is one talk.
as I see it, like in terms of a light box virtual machine,
Yeah.
like, do you have to set up all the networking between them, or do they see each other?
Yeah, they
Like,
see each other.
They see each other
As you see,
in terms of file system. Like they share the file system, but I understood that they had like, okay, this is your part of your like the change root is like.
it's always using the host file system.
But isolated.
No,
or not.
It's the host file system. If I cd there, let's see if I can show you that. So, oops. Let's see if I can show you that. So, if I have this, okay. Okay. See there? These are all my containers inside of this computer, laptop. As you can see here, you have a Debian box, you have the Drupal container I created, you have a Fedora, and you have another Ubuntu box. And if you go inside of, for instance, the Debian box, you will see that the root file system is there. And this is actually what Linux container mounts as the change root. Because if you go there now, you will see that a full operating system is inside. By comparison, if I go here, for instance, to the root file system of this laptop, it's very similar. So what it does is it uses the file system of the host. So it actually can connect to other hosts via the file system or via mounting via network. So you can choose. You can use NFS for mounting the other hosts, but I think that will complicate a little bit. The easiest way to do is like when you have here the Debian and you have, let's see if I have here var, oh, I don't know, I don't have, but I have varlog, okay? So these files are always changing, right? Because they are logs, they are always changing. If I mount this via AUFS, what's going to happen is, even if you had files when you mounted the first file system, the old files are the ones that are going to appear, because that's how AUFS works. It mounts and it just sees the latest files. So it doesn't matter what you had as the beginning, because it's using, you can mount actually 2 mount points and then convert it to 1. Yeah, it's kind of hacking, deeply hacking. ¿Más cuestiones?
Any more questions? We have time for one or more or less.
I would like to see one question, even, well, an easy one, because that was complex.
Anyone? No? Yes. Going there.
So if I understood correctly, like when you start the machine with Docker, you don't need to puppetize it?
No, in the case of Docker, no. That's why I kind of tricked you guys into thinking that it would take always 2 minutes, and then show you don't have to take 2 minutes.
So if you have like a configuration file that like in normal times you use puppetize, like an Apache configuration with the virtual hosts, and if you deploy the first one with Docker, how do you, if you want to add a new virtual host, how do you manage that update?
By the layers, exactly. So if you have those layers there, let me go back to the slide if I can. So this slide shows exactly that. Like, you see there the writable part? It says writable. See? Okay, so imagine on that writable part, you have configuration files. Okay? And imagine that, for instance, here you have Apache. Yes. I think it's there. So you have Apache there. So the Apache part is like the libraries and the executable part, the binaries, and then you have the writable part. Okay? So, but since it uses AUFS, you don't really need to think about it, because as soon as you have a file there, it will recognize it's the latest file, so it will overwrite, in terms of visualization, the latest. Even if you have a configuration file and you change it, it will use always the latest one. I don't know if that responds to your question.
Yeah, so if you do have several containers or several Dockers,
yes,
how do you propagate that change?
You can commit.
Okay.
That's the cream of it. Yeah. You can just say, okay, this configuration, I'm okay with this. I want to commit this to the main file, to the main image. Okay, cool. I'm not going to waste more of your precious time, but just, oh, sorry, this is really not. What happened here? Hakuya is hiring, like Hernani said yesterday, so if you are interested, just come to one of us in the end, or go to that place there for careers. And, well, thank you all for coming. I hope you have liked it. It's very complex, as I said.
Thank you, Ricardo.